All right, this is our seventh example from the section 7.6. I think this is the third example of solving using the Gauss-Jordan elimination method. So here we have a system of equations. 2x minus 3y is equal to 12, and 6x minus 9y is equal to 36. If you notice that if you multiply the top equation by 3, you'll get the bottom equation, and so that'd be kind of a cue that we might have one of those special situations where you might have a no solution or an infinite solution. So we're going to go ahead and go through the Gaussian elimination, Gauss-Jordan elimination. So we're going to want row 1, column 1 to be a 1, row 2, column 1 to be a 0, row 2, column 2 to be a 1, and then row 1, column 2 to be a 0. So we'll go ahead and write our augmented matrix here. And if we want to make a 1, we're going to divide by whatever that number is that we want to make 1. So here it's 2. So we're going to divide by 2. More formally, that would be 1/2 row 1 replaces row 1. Or you can think of it as row 1 divided by 2 replaces row 1. So when we do this, we're not doing anything with row 2. So row 2 is unaffected. Now, looking at row 1, 2 divided by 2 is 1. Negative 3 divided by 2 is going to be negative 3/2. I'm going to leave it as a fraction. It is actually a nice decimal meaning like a terminating decimal. It's negative 1.5, so it wouldn't hurt to leave it like that. Something that you wouldn't want to really write is like 1/3, because that is 0.3 and then repeating, so it's a little bit messy. And then 12 divided by 2 is 6. Okay. All right, so we've accomplished the first step of the Gauss-Jordan elimination. The next thing we want to do is we want to make this 6. We want to make that a 0. Now that's in column 1. So if it's in column 1, we're making a 0. We want to use row 1. Now we're going to use the opposite of 6, which is negative 6, and we're using row 1. So we're going to use negative 6 row 1. So negative 6 times row 1 plus row 2, and that's going to replace row 2. So negative 6 row 1 added to row 2, that's going to become our new row 2. All right. So 1 times negative 6 is negative 6. Negative 3/2 times negative 6, or negative 6 times negative 3/2. I'm going to go ahead and do that over here. So negative 6 times negative 3/2. You don't need a common denominator for multiplying fractions. It's just straight across. So we could say that this is negative 6 over 1 times negative 3 over 2. So negative 6 times negative 3 would be positive 18, and 1 times 2 would be 2, so that's going to reduce to 9. And then 6 times negative 6 will be negative 36. Row 2 is 6, negative 9, and 36. And so when we add that, negative 6 plus 6 is 0. 9 minus 9 plus negative 9 is 0, and negative 36 plus 36 is 0. So we got a row of zeros, and so we're going to go ahead and see what we got going on here. So we have a row of zeros, and so this is going to be a candidate for an infinite solution. That bottom row there is going to represent, it would be 0x plus 0y is equal to 0, so essentially you have 0 is equal to 0, and that's a true statement. So this is going to be an infinite solutions, and if you were listening at the beginning there, if you take the first equation and multiply it by 3, you get the second equation. So the second equation is a multiple of the first equation. So that means they're really the same line. So it's infinite solutions, and so any solution is going to be a point x comma y that's on the line, and you can use either line. The 2x minus 3y is equal to 12. The 6x minus 9y is equal to 36. You can use that, or you could use x minus 3. I'm writing with my finger here, so give me a second. Or x minus 3/2 y equals 6. Any of those would work. I'm going to go ahead and use the 2x minus 3y is equal to 12. So our solution is the set of all points x comma y such that they are on the line 2x minus 3y is equal to 12. And so there's infinitely many points on the line, so infinitely many solutions. Okay, that's it for this video. I'll see you next time.